Hello and welcome to the demonstration video for my submission for the Ask Why Data Labs Hackathon. I like to call my submission as AIRDASHER, which stands for Analytical Intelligence for Route Development and Strategic Handling of Economic Resources. As the name suggests in a nutshell, my solution provides analytics and machine learning intelligence for route development for airlines, and it also provides strategies for the handling of economic resources of an airline like capital and fleet. So this website is online currently, and it covers 3 different applications which we will go through one by one. The first one and the main application being the analysis and development of new routes for airlines. This is done by a 3-step process, which is city selection, route selection, and cost and resource analysis. So this is step 1, which is city selection. But before doing anything, let me just describe the parameters. So forecast year basically means till what year do we want to see forecasts for. Sample basically means what airlines network do you want to use to develop new routes for, which you can see in this map over here. And route type basically means that if I want to add a city to this particular network, do I connect the city to one of the hubs of the network, which are these orange circles, or do I connect it to any airport in this network? So with these parameters, let me just update. Okay, so shown here are the cities which are being considered to be added to the network. So for each city, you are provided a description, and you also provided the air traffic demand coming into and out of, in this case, Kanpur. We are also provided information about the different macroeconomic factors such as population, economics, education, and tourism. We can visualize how these factors have varied historically over time and how these are expected to look in the future. So this information is provided for all the different cities listed over here. Let us go with let's say Nagpur. So for Nagpur, we are provided routes to connect Nagpur to our network. So for, let's say, Nagpur to Delhi, we are provided with the forecasted total air traffic demand for specifically for Nagpur to Delhi route, as well as Delhi to Nagpur route. We're also provided market information, basically the number of existing flights between Nagpur and Delhi, Delhi to Nagpur, and the kind of fares that we see for such flights. And we are also provided information about how Nagpur and Delhi are connected by other modes of transport, in this case railways. So this information is provided again for all the different routes, and let us choose Nagpur to New Delhi as the route that we want to select. So for this particular route, now we want to check whether this route is feasible or profitable in terms of the parameters that we have over here. The parameters we have are fare selection, which basically means we can select the kind of fare that we want for our newly added flights. We have cost parameters, which lets you provide information about the kind of fixed operating and other costs that will be involved with the addition of a new flight to your network. We can also set a target minimum profit margin for this particular route. Fleet parameters basically mean how many narrow body and turboprop flights are available in my fleet and what capacities do they carry. And we also have other parameters such as analysis point. What this means is that in 2028 we let the model reanalyze the demand and capacity, and if required, in 2028 it can add new aircrafts to the given route. So this just provides an additional layer of flexibility in terms of the strategy of adding flights to our route. And we have a couple of other parameters here, so let me just update. And we can see certain feasible options over here. Let me just go through one of them. So what this option says is that in 2024 you add 2 turboprop flights for this particular route. It provides you the market share information, so how many people going from Nagpur to Delhi by flight will prefer your airline. So right now it's around 16% for both Nagpur to Delhi and Delhi to Nagpur, and it also provides information about the total cumulative earnings, expenses, profit margins, demands, capacities, and the occupancy rates. So by tweaking these parameters, you can check for feasibility and profitability. Coming to the next application, which is analyzing new airports. So for this, again, we have a forecast year parameter. Let me just update that. So shown here are a list of cities which do not currently have an airport, but which have enough forecasted demand and growth to consider having an airport in the city. So for example, for Faridabad, you can look at the same information that we have seen earlier, and we can consider whether to add an airport to this city or not. So the addition of a city can also stimulate a demand, air traffic demand, which is quite an interesting feature over here. Lastly, coming to the general statistics feature. Yeah, so in this page we can get to see and visualize certain insights which we can extract from our data set. So we plot the different aircraft types for the flight distance versus flight duration, and we also define something called as an ideal pricing, which is completely distance based. So for the fares versus distance graph, we plot a line, we fit a line through the data points, and this is considered to be the ideal pricing, which is completely distance based, as you can see over here. So what kind of insights can we get from this data set? So for example, we can get information about the flight limits. So if we check the turboprop, we can see that most of the flights of turboprop are within certain boundaries in terms of flight duration and flight distance, which are mentioned over here. And similarly for narrow body and wide body, we can do the same. We can also get information about the average speed of different aircraft types, and the speed is basically the slope of the line which is fitted for each aircraft's data points. We can again see turboprop being much lesser in speed than the other two kinds of aircrafts. And we can also get information about the pricing, which uses this ideal distance based pricing information. What this basically means is that for the same distance, we can expect turboprop flights to be underpriced by 2%, while narrow body and wide body will be overpriced for the same distance. And similarly, we can get several other insights from this data set that are manually created, and this is basically the entire gist of my solution. So this website is online right now, and I would highly recommend visiting this website and checking and tweaking the different parameters to try and understand how such a solution can actually be beneficial for airlines in their route development process. So thank you for your time, and I hope you enjoyed this demonstration. Thanks.